Hey guys, let's see this question. The question says a block of mass 0.18 kg is attached to a spring of force constant 2 Newton per meter. The coefficient of friction between the block and floor is 0.1. Initially the block is at rest and the spring is unstretched. Okay, an impulse is given to the block as shown in the figure. The block slide a distance of 0.06 meter and come to rest for the first time. Okay, that means we have final velocity of block is 0. Okay, the initial velocity of the block is in meter per second is v equal to n by 10. Find the value of n. We have to find the value of n, and here we have given mass of block, that is 0.18 kg. Second thing, we have spring constant, that is 2 Newton per meter, and coefficient of friction is 0.01. Okay, now this question is from IIT Advanced and it was asked in 2011. So first we understand the question. So we have given that there is a block and we give a impulsive force to the block such that this block push the spring, this is spring, and finally it come to rest, because spring, whenever it start moving, it will push the spring, and spring will also apply a force to the block in opposite direction, and that's why the block will come to rest. That means the final velocity of block is 0. We have to find the initial velocity of block that it will gain when an impulse will be applied on the block. That means we have to find u. Here we can apply work energy theorem, because if we go for laws of motion concept, then it will become complicated. That's why we have to apply work energy theorem, and it will become a simple question. We know that the statement of work energy theorem, the work energy theorem states all forces, work done by the all forces equal to change in kinetic energy. That means we have to find the work done by all forces that is acting on this block, and we have to equate to the change in kinetic energy of this block. So first we will find what forces are acting on this block. So first we have to draw FBD of this block. So I'm going to redraw the FBD here. We can see that block is attached to spring. That means a spring force should act on this block, and the direction of this force will be towards left. This is the spring force due to spring. Second force that will act on this block is friction, because this surface has friction. Okay, third is going the force that will act on this block is mg, and direction is vertically downward. And fourth is normal reaction. So these four forces are acting on this block. So since the block is moving in horizontal direction, that means work done by mg and work done by normal reaction will be 0, because the angle between these forces and displacement is 90 degree. That means if the angle is 90 degree, then work done will be 0. That means work done by mg and normal reaction is 0. Now we have only two forces that for which we have to find the work done. First is the friction force and second is the spring force. Here we can assume that when the block compress this spring, the length of spring decreases by x. That means change in length of spring is x, and that's why the movement of this block is also x. So we can write the equation for spring work done by the friction force, that is equal to work done by friction force, that is force due to friction, that is the equal to mu mg, mu into n, and n is equal to mg, because n equal to mg we can write it directly, and displacement of block, that is x. Now we can see the direction of friction force and displacement is in opposite direction. Here block is moving in right direction, but friction will act on towards left direction. That means we have theta equal to 180 degree, and we know that cos 180 degree is minus 1. That means work done by friction is equal to minus mu mg x. This is the work done by friction. Now work done by spring force, and that is equal to, from figure also we can see direction of spring force. When this block is moving towards right direction, when block is moving toward right, the force of friction that will act on the spring, that block, is towards left direction. That means ki angle between displacement and spring force is 180. So that means ki work done by spring force is negative. So we can write minus, and we know that work done by spring is half k x square. So that means ki we have is work done by spring force is minus 1 by 2 kx square. Now let the initial velocity of block is v. Initial velocity of block is v. That means initial kinetic energy is equal to half mv square, and finally the block will come to rest. That means final kinetic energy of block is 0. Now we can put these all values in work energy theorem, and that theorem states that work done by all forces is equal to change in kinetic energy. So we will put these all values in this formula. So work done by mg plus work done by normal reaction plus work done by friction plus work done by spring force is equal to change in kinetic energy. That means change in kinetic energy, that means final kinetic energy minus initial. Finally block is going to stop, that means final energy, kinetic energy is 0, and initial kinetic energy is 1 by 2 mv square. Here we will put the value of work done by mg, that is 0. Normal reaction is also 0. Friction force is minus mu mg into displacement, and work done by spring force is also minus half kx square. So here we can rewrite this equation, minus half kx square equal to minus half mv square. Now we can put value, and we have to find value of v. So we will put the value of all the given constant. Mass is 0.18 kg, mu is 0.1, force constant is 2, and x is 0.06. So we have to first put these all values. Here negative sign will be cancelled, and mu is 0.1, mass is 0.18, g take g 10, and x is 0.06 plus half value of k is 2, x is 0.06 square, and mass of this block is 0.18 kg by 2 into v square. Now we can solve this. So we will get this is equal to 0.0108 plus 0.0036 equal to 0.09 v square. And now we can solve it. This left side will become 0.0144 and right side will be 0.09 by v square, and on dividing this we will get 0.016. That means the value of v will be 4 by 10 and value of n is equal to 4. So this is the answer. Let question is asking the value of n. So answer will be value of n will be 4. N is the integer, the value of 4 will be 4. Value of n will be 4. So this question is from IIT Advanced 2011 and I hope you have got the answer. Thank you.